previous video, we have trained a machine learning model to predict or to classify the iris flower type given the sepal and petal length and width as 4 features, right? So these are the models we have trained previously and using the XGB estimator. So a very quick recap. So here we have defined the XGB estimator. We set the hyperparameter. We created a job name, and then with the fit function, we have trained a model, right? So today we are going to see how we can use this model to make some inferences, okay? So the model artifacts are stored in these files. So these are 4 different models we have trained. All right. Now, because there are multiple ways of deploying the models and making the inferences. Now, today we are going to see some of them, and in the next video also, we will see more standard methods of inference. Now, the XGB estimator, we still have access to it because in the same notebook, we have trained the model. So this XGB estimator is still alive, right? So we can use this estimator to deploy the model and make some inferences, but that might not be the general case because we might not want to deploy the model as soon as we trained it, right? We might train multiple models, then deploy them, then see which one is performing well, and then one of the model we might deploy it into the production system. So at that time, we will not have access to the XGB estimator. By then, this notebook won't be alive, right? But today we will see how we make inferences when we still have access to the XGB estimator. Okay, all right. Now, first let's deploy the model as an endpoint. Okay, so to the model, we are going to give the feature values in the form of a CSV serializer. So that's why we are importing the CSV serializer function from Sagemaker. Okay, and then so using the estimator, we can simply call this deploy function. Okay, now when we deploy a model, we need 3 things, right? One, what the model is or this estimator is. Sorry about that. And then how many instances we want to deploy the model on. I mean, this depending on the traffic, we might want to create multiple endpoints or we might want to create one endpoint with multiple instances so that if 2 users are trying to make the inference at the same time, they'll get the response immediately without one waiting for the other to finish, right? So that's the number of instances. And then the instance type. Usually we use bigger instances to train the model, but for inference, it's only doing the arithmetics on the weights, right? So we don't necessarily need a bigger instance for making the inferences. So we usually choose a smaller instance for the inference. Okay. Now this is not the best way to deploy a model because we would like to configure multiple parameters as we discussed. What should happen when multiple people trying to make the inferences? Should it be serverless endpoint, etc., etc. Today we are making it keeping it very simple. We are going with all the default options. We are simply providing how many instances and on what instance we want to deploy the model. So we deploy the model. It creates these 3 steps. Now in the later parts of the videos, we will see all these 3 steps, how we can create these 3 steps explicitly using a number of parameters which are important for production systems. Okay, so today we are going with all the default options. Now first it will create the model. Okay, So the estimator, first it will create the model and then it will create what is called this endpoint configuration. And in the final and third step, it will create the endpoint. Now I'm using the latest version of SageMaker, but in the previous version, as soon as we train the model, like here, as soon as we does the fitting, SageMaker used to create a model by default. So when we do this deploy, it directly used to create this endpoint config with the endpoint. But in the latest version of SageMaker, it's not creating the model by default. So when we do the deployment, it first creating the model, then the endpoint config, and finally the endpoint. Again, don't worry too much about all these. We are going to have more videos on each of these topics with all the parameters they take. Okay, so we have deployed the model. When we deploy, we get this predictor back. Okay, we can use the predictor also to make the inferences, but again, that won't be the standard practice, right? Because this predictor will be available only for the first time when we deploy it. We also have an endpoint, which is a standard way of making the inferences. We will see that in a minute. But first, let's see how we can use this predictor to make the inferences. Okay. So with the predictor, we simply call the predict function and we supply our input features, right? This is this iris flower classification model. As you know, we have only 4 features, right? The sepal length, width, and petal length and width, right? So here we are giving those 4 values to make the prediction, and we get the class as 2. Okay. We can map the class to the flower type going back to the data set, right? Now let's look at the endpoint, how we can do this with the endpoint. Because here we have not provided any name for the endpoint, SageMaker simply take the training job name, the name we gave when we were training the model. It uses the same name for the model, endpoint configuration, as well as endpoint. Okay. But if we don't know the endpoint name, from the predictor, we can get the endpoint name back. So this is our endpoint name. Now, in order to hit the endpoint, we need the SageMaker runtime. Okay. So using the Boto 3, we will access the SageMaker runtime. And then we use the SageMaker runtime to invoke the endpoint. So first this is our input payload or the feature values. And then here we are hitting the endpoint using the SageMaker runtime. The endpoint name, where do we want to hit? And what's the input format? It's a CSV or /text format. And then the body is the features. Okay. So this is what we get, the response. It contains lots of information like this HTTP headers, date, time when we called, the content formats, etc., etc. But it also contains this body. So usually this body contains the most important information. The rest of it is metadata. So within this response body, we have the a predicted class. Okay, so we are just reading the body and then decoding it, because it's usually what is written is this binary string, right? So we have decoded it, so we get the class value. All right, now with the endpoint, we can make multiple inferences also. For example, here this is one flower and this is second flower. So these two we have separated by a/n. Okay, process exactly similar. Hit the call the SageMaker endpoint using the SageMaker runtime, endpoint name, content type, and the payload. So instead of having one record, here we are supplying 2 records. So we get 2 responses back, right? So in this case, both flowers happen to be of the same type, right? Now, let's look at, so these are 2, right? I mean, this won't scale, right? We don't manually create this string, right? We might want to read from a file where we have multiple records and we wanted to make the predictions for all those records / forwards. So here we have the infer file which we created previously. Remember, this has 4 columns, 4 features. We have removed the target variable from this file. So we open the CSV file and then we get the content of this file. I'll show you how this file looks like. The same process. Okay, we call it, and this file I guess contains about 50 records. That's 1/3 of the data we used for testing the model. So we get the response. This contains the 50 classes, one for each of the input record. Now let me show you this file. Okay, as you can see here, it's just these 4 features separated by a /n. Again, next set of features separated by /n. So it's just the same as this. Okay, here we have extra spaces, but you can read the data from CSV file and you can make a string like this and make multiple inferences from a single endpoint. So this is when we have a local CSV file, right? Now let's say we have the file on S3, okay? All right, so this is where we have the file. Now there are multiple ways to read an S3 file, or the CSV file from S3. So here I'm showing 3 different ways. Now the standard and the most easy method is directly this pandas read CSV. So provided we have the AWS credentials configured, we will be able to read the CSV file directly from S3. Now the second method is using another library called this AWS Wrangler. So with the Wrangler, we will be able to access data from multiple sources, not only S3 from the databases, from Redshift, etc., etc. So this Wrangler is a more generalized method. Okay, and the third method is using the S3 client. Okay, so using the Porto 3, here we are getting the client through S3. We can also get a resource to S3. So once we get the S3 client, we provide the bucket name and the file key, right, with the get object function or module. So we get an object back, and then the body contains the actual content of this file. So with the read CSV, we are reading the content of this file. Okay. And here with these 3 lines, we are doing just a bit of manipulation to make exactly the same string. Okay, we are using this this string buffer to read the content of the file, and then finally we are preparing this payload in the CSV text format. So this one, the output from these 2 lines is exactly the same as the output from these lines. So by this line, we have read the content of the CSV file, and then we are simply preparing the payload here. Now we can again hit the runtime, the endpoint using the runtime. We get the same response back, the 50 predicted classes for the 50 records. All right. Now we get charged from AWS as long as this endpoint is alive. The reason is because this instance we have chosen for creating the endpoint, that's reserved. So this instance is dedicated for us, and the endpoint is live. Okay, so even if we are not using the endpoint, we get charged for this instance. So for production systems, we make the endpoint live and keep running all the time because we might want to make inferences at different times. but this is for demo, right? So we can use the same SageMaker client to delete the endpoint. All we need to do is we supply the endpoint name. So what it does is it delete the endpoint name as well as the endpoint configuration. Now throughout this process, there are a couple of things happen. Let's look at them on the SageMaker console. Okay. All right. So when we deploy the model, as you saw, it first created, let me go back. So it did three things, right? When we deploy the model, it created a model, it created an endpoint config and endpoint. Let's see them on the console. Okay, so the first thing it did is it created this model. So if you go under Inference on the SageMaker console, go under Inference. So the first thing it did is it created a model. Okay, so these are the different models, but this is the one which created the model. Okay, so if we go here, the two most pieces of information are where can this code run. So this is the Docker container which is used to train this model. Now XGBoost, we are using inbuilt version of XGBoost. So this container for training and inference is the same. But most of the other models, the training container and the inference containers are different. Okay. All right, this is one set of information, and the second information is this. So these two things will make up a SageMaker model. So basically the model artifacts, the weights of the model, and then where can this model run. So these two together will make a SageMaker model. Sorry, this is model ARN. This one is the Docker container. Okay, so the Docker container plus the model artifacts will make a SageMaker model. So the model name is this. This is when the model is created, and the role which is used to create the model. And as you know, every resource or every artifact we create on SageMaker will have its unique ARN. Okay. All right. These settings, again, we are going with the default, so nothing is here, but we can create some keys and values like which model it is, what version, for what project, maybe if we are billing to some client, what client, etc., etc. Right? That's the first thing, the model. And the second one which was created is this endpoint configuration. So whenever we delete an endpoint configuration also gets deleted. For example, let's look at one of these. Okay. So the endpoint configuration, which will have information about the model name. So we can go back to the model page we saw before, the container and the artifacts. And it will have also the training job. So if we go back to training job, then we can see lots of information like where we have, from where we use the training data and all those things. So how much time this model took to train, when did we train the model, the job name, etc. So I'll show you the important pieces. Yeah, so this is the data we used for training the model, and it will also show the hyperparameters used for training the model. Okay, and then this is the validation data. So validation data, training data, and the instance we use to train the model. These are some model metrics we can get from the CloudWatch logs. We will see in later parts of the video. And then these are the model hyperparameters. Some we set, some default. And again, we will cover all these in more detail. So here, because this model took only 90 seconds, we don't have the data to show here. But we can see here the model performance related metrics, how is the training accuracy and error, the validation accuracy and error are changing with time or the number of steps. And then we have the instance related metrics. So how much of CPU, GPU, the storage, etc. are being used. And then the logs contain all this information. And the search log is an additional service from AWS, which makes it a bit easier to search these logs. Okay, so basically this information we can search using this service in a bit more easier manner, right? So when the model takes a longer time, we will be seeing a multiple plots here. Okay, that we will cover in some other video. And here we have the model artifacts location, and finally the tags. Okay, that's the training job related information. And then let's go back. So this is the endpoint configuration, right? All right. Finally, let's go to the endpoints. Endpoint configuration and endpoints. All right. This is our endpoint. Version 1. Okay. So again, we'll cover the important pieces of information. Again, we will see the model name and the training job. The links are there, so you can go there and check. Now, this is the instance we are using for the inference. Okay, and how many instances are we currently using? We can configure the endpoint configuration so that, as I mentioned before, we can have serverless inference, we can have multiple instances, etc., etc. So all that such information will be available here. Okay. All right. This is that endpoint name, and as you see, it's a real-time endpoint. Now this data capture, so when we deploy the model, as we make inferences, we can enable so that the data we are using for inference get captured on S3 location. So this we will use for model training, so that we'll have the data used for inference, as well as we have the predictions. And when we have the actuals, for example, let's say it's a customer churn model, and eventually we know whether a customer churned or not. Then using these three sets of information, we can find out how the model is performing over the time. Okay. All right. What else? Yeah. That's it. I'm going back to the notebook. All right. So we have done all this. We have covered multiple records. All right. So we have deleted. We can delete the endpoint. Now I just want to show you this endpoint is live, right? Endpoints. So this endpoint is live. It's in service. Now from the UI also you can delete the endpoint. So go here and delete the endpoint. Okay. All right. That's for live. And then let's look at the batch inference. Okay. The batch inference means we will have a file on S3 or maybe local. We want to make the predictions for multiple files. Now this is not a live instance. So it takes up to 5 minutes to spin up the instance and prepare the model so that the inferences can be made. Okay. So here we have the batch input. As we saw before, we have created a iris infer file we have stored in this S3 location, batch transform, right? And then the output from this one is going to be another file, right? Unlike here, we don't get the response as a dictionary. We get the output as a file. Okay, so we have to specify the output path. Now, our batch transform folder, as you can see here, it has only one file called irisinfer. And then using the estimator, here we are creating a transformer, right? Again, to do the batch transformer, we need to define how many instances we want to use and the instance size, right? And where do we want to save the output to? Okay. Now, if imagine if it's some maybe object detection algorithm, we might want to detect objects on, let's say, 10,000 images, right? If we do one image by one image, it will take quite a lot of time. So in such scenarios, we might use multiple instances. For example, we might use 10 instances so that the transformer time or the inference time will be reduced by 10 times, because these are 10 instances working independently, and the data automatically gets divided into 10 chunks, and each instance process its own chunk. Okay. All right. So we have the transformer, and then we call the transform. Okay. We simply provide where is our input data, again the data type and the content types, etc. How we are splitting the data in this file, I mean how the records are split. So each record is in a new line, right? So this wait function, it simply wait within this cell until the job is completed. Similar to training, similar to training, there will be lots of information in the logs. So it's doing the inference, and finally maximum payload in NB, it should have some info. So once the job is completed, if we look at in this folder, so here we chose the same path for the output as input, right? So this is our input file. So Sagemaker, it has created this output file, right? So for every .csv file in this folder, Sagemaker create a corresponding .output file. So when we do the batch transform, the path can have multiple input files, not just one file. Okay, because here we have one file, it has created this one output file with this postfix.out appended. Okay, so let's download this file, csv.out file. Here we have downloaded, and if we look at the content of the file, this is how it looks like. So these are the 5 predictions for the top 5 records. Okay. All right, we have covered a lot. We have deployed the model, and we looked at multiple ways of making the inferences using the endpoint, using the predictor, and also the batch transform. But this is a bit long video, but it has covered multiple ways of inferences. Okay, thank you very much.